All right, these are the answers to the semester 1 exam review, first one that we have. And it says, what are the x and y intercepts for this? So for an x-intercept, we're gonna let y equal 0. So if we put 0 in here, I wanna know when this expression equals 0. If I add 9 over, then what I get is this. And I think sometimes it's just best to look at it. You're saying something squared equals 9. So that something, this x plus 1, that could equal 3, because 3 squared would equal 9, or that x plus 1 could equal negative 3, because negative 3 times negative 3 would also be 9. Right? So I think sometimes it's just easier to look at it and say, what am I dealing with? In this case, x could equal 2. In this case, x could equal negative 4. Either one of those would make that equal to 9. And so we get two x-intercepts, 2 and negative 4. Okay. As far as the y-intercept goes, we're just going to let x equal 0. So we're going to put 0 in there and get y equal 1 squared minus 9. 1 times 1 is 1, and 1 minus 9 gives us negative 8. All right, so there's our y-intercept for that. All right, for this one, we have 2 points, 2, 6, and negative 6, 10. We're supposed to find the distance and the midpoint. We'll start with the midpoint. That's a little easier. We're just trying to find halfway between the x and halfway between the y. So halfway between 2 and negative 6 would be negative 2. That's 4 away from each of those values there. And halfway between 6 and 10 is 8. 8 is 2 away from each of those. If you ever get confused, you can always take the numbers like 2 and negative 6 and add them together and divide by 2. You get negative 4 divided by 2, which is negative 2. That'll always give you that value as well. Okay. As far as the distance goes, we need to think of this in terms of like a right triangle. So if you think like 2, 6 is up here and negative 6, 10 is over here. I want to know what this distance is. I want to know what this distance is. So as far as the y goes, between 6 and 10, that's a distance of 4, 10 minus 6. And from 2 to negative 6, that's a distance of 8. All right? So we're going to go 4 squared plus 8 squared equals our distance squared. So we get 16 plus 64, that's 80, equals our distance squared. So our distance would be the square root of 80, which is around 8 point something or other. Let me just real quick, 8.944. Find the slope-intercept form of the equation passing through these 2 points. So what we want to do is find the slope between these. So our slope will be y minus y over x minus x. I'm going to get negative 4 over positive 8. I get a negative 1/2 as the slope. If I look at kind of this, that makes sense. Definitely negative. We're going down. The 1/2 kind of works for me. So now I'm going to put this in point slope form to start with. So I'm going to pick one of these points. I'll just go ahead and pick the 2, 6 and go y minus y equals slope times x minus x. Okay. They wanted in slope-intercept, so that means y is by itself. So I need to distribute this. Y minus 6 equals negative 1/2 x plus 1, and then add 6, and we end up with y equal negative 1/2 x plus 7. A couple other ways that you could get that. This is the way I chose. As long as you got to there, that's all that counts. And it says, what's the slope of a line that's perpendicular that goes through there? So this slope is negative 1/2. If we were parallel, we'd have the same slope. But perpendicular, we would flip that, change the sign, so it actually would just have a slope of 2. Right? This page here gives us 3 different functions up on top, and then we're asked to find some values. So g of negative 4, we're going to put negative 4 into the g function. That means we're going to go negative 4 squared plus 4. That's 16 plus 4, which gives us 20. For h of negative 3, I go here. Now, because it's negative 3, I have to find the one that works for that. Negative 3 is less than negative 1, so I'm going to use the top line here. So I'm going to use x minus 4. We'll put negative 3 in there. We'll go negative 3 minus 4, which is negative 7. Okay. For f of x plus 4, we're going to put x plus 4 into this. So instead of negative 5 times x, we're going to do negative 5 times x plus 4 and then minus 2. All right, distribute gives us negative 5x minus 20 minus 2, and put that together, we get negative 5x minus 22. Okay. Then we get this crazy one, this f of g of h2, so we're going to start inside, h of 2. 2 is bigger than negative 1, so we're going to put 2 right there, and go negative 2 times 2 plus 3. That's negative 4 plus 3, which is negative 1. Okay, so h of 2 is negative 1. That's going to go into the g function now. So we're going to put negative 1 in there and go negative 1 squared plus 4. That's 1 plus 4, which gives us 5. So all of this is 5. So that means 5 now is going to go into the f function. So we're going to put 5 right there and go negative 5 times 5 minus 2. That's a negative 25 minus 2, which gives us a negative 27. So you just kind of work from the inside and work your way out. Okay. For this one, they want to know the slope of the y-intercept, so that means we need to get y by itself. We're going to add 15x over to here. 9y equals 27 plus 15x. All right, and then we're going to divide by 9. So everybody gets divided by 9. I get y equals 27 divided by 9, which is 3. And then 15 divided by 9, if we reduce, is 5/3, or you can leave it as 15/9. I just wouldn't make it a decimal. This is your slope, this 5/3 or 15/9, and the y-intercept is 3. Then we get to this graph here, and we're asked to find some information about it. First, the domain. You can see that as far as x goes, we go from -3 to 1. We have an open circle in the -3, so we're not including that, but we are including the one with the closed circle. So that means we're going to have a parenthesis around the -3. We're not including that, but around the 1 we'll have a bracket that does get included. Okay, so the domain again is our left to right. For the range, we're going from bottom to top, and so we can see that -4 is the lowest value that's on here. 0 is the highest value, so we're going -4 to 0, and we do have values included on both of those, so we will include that there. Okay. When is the function increasing? We're increasing from here to here, so -2 to 0. And remember, when we do this, we're talking about the x values. So for what x values is it increasing? From x -2 to x equals 0. When are we decreasing? From -3 to -2. Okay, put parentheses around that or bracket on the -2. We just can't bracket the -3. And it's decreasing from 0 to 1 as well. Okay. Where does the function have a relative maximum? So a relative maximum is when we have like the top of the hill. So that would be at x equals 0. Where we have a relative minimum, that's like the bottom here. So that's at x equal -2. Okay. And then the last one, what is the average rate of change from -1 to 1? So if I go from -1 to +1, I'm looking for the slope of this line. This line went from -2 to -4, so it went down 2, and it went over, and this is where it's deceptive, because from -1 to 1 is also 2. The scale is different than the upper scale. So it went down 2 and over 2, which means the average rate of change was a -1. Okay. For 17, it says what two functions were composed to create it? What did you put inside of what? So it looks like the inside function for sure is this 3x plus 4. That'll be our g function, which was put into x squared. And you just need to have this x here. You need to have somewhere for this to go into to create that right there. Okay. Find the vertex, y-intercept and stuff. For the vertex, they give it to you in vertex form. It's the opposite of what you see with the x, so 4, and exactly what you see out here, -8. So at 1, 2, 3, 4, -8 right there, that's where your vertex is, okay? As far as the y-intercept goes, we're gonna set x equal to 0. So if you put 0 in there, you're gonna get -4 squared minus 8. That's 16 minus 8, which is 8. So our y-intercept is up here at +8, okay? So this is the vertex, this is where it turns, and then where you have an axis of symmetry. So if we kind of draw this in, we're gonna make that turn, come back up like that. So this is a little sketch of what that looks like. All right. Then 19, we get this equation. We're going to put this on our calculator. So let's go ahead and go to y equal and type in -16x squared plus 78x plus 96. All right, I'm going to go to a regular window here. And then I'm going to change because our x is our time. So I'm going to go from 0 to say 5 seconds. See if that's enough. And then our y can be -10 to, we'll go to 200 feet. Let's see what that looks like. All right, so it looks pretty good. I just need a little more time, so I'm gonna give myself, say, well, we'll give ourselves 8 seconds this time, see if that's enough. So there it goes up, and sure enough comes down right there. All right, perfect. What is the greatest height that the rock will reach before it hits the water? So we wanna see this up here. So I'm gonna go second, calculate maximum. I just need to be to the left of that. So I move to the left of it, hit enter, then I need to be to the right of it. Hit enter again. And our highest point would be 191.0625 feet. So 191.06, we'll round it to 3 decimal places. All right. Find the time which the rock hits the water. We want to know when we are on the ground. So now I'm going to calculate our 0. When are we on the ground? Again, we do a left bound and a right bound on this. I'm just going to bring it a little closer. All right, left bound, right bound, make sure you're in the negatives there. Hit enter, and we're at 0 at 5.893 seconds. Okay. How long does it take the rock to reach the same height that it was when it left Henry's hand? So this is the height that it left his hand. If you look here, that height is 96. You know, that would be at time 0. Okay, so I'm just gonna go ahead and put a line at 96. There's that height where it left, and this is the time where it's added again. So if I go calculate, intersect, enter, goes to that time at 4.875 seconds. It's right at that height of 96 again, okay? And then the last one is probably the easiest one. What is the height after 3 seconds? You can just hit trace, type in 3 at x equal 3. The height is 186 feet. So a good little problem that kind of goes through all the different things about graphing those lines and stuff. All right, number 20 wants to know where vertical asymptotes, holes, and horizontal asymptotes are located. As far as horizontal asymptote, this is what we do when we let x get bigger and bigger and bigger. And in this case, up top, we just have a single x, but on the bottom we have x squared. So this x squared will get bigger much faster than just a plain x will. And therefore, the bottom is going to get significantly bigger than the top. And therefore, we're going to head off to a value of 0. And so over time, if you can kind of imagine this is going to level off and approach 0 eventually. So that's what we mean by a horizontal asymptote. What happens when x gets super, super big? If that had been an x squared, then we would have done the ratio 5/1, and that would have been 5 then. As far as our vertical asymptotes go, well, we're going to factor this. So this factors into x minus 6, x minus 3, and up top, that factors into 5 times x minus 6. So you see how the x minus 6's cancel? When that happens, that's going to create a little hole in your graph at that value. So at x equals 6, we'll have a little hole. But the asymptote will be the thing that doesn't cancel. So at x equals 3, you're going to have an asymptote. So if you were to see 1, 2, 3, our graph would probably look something like this then, right? But then at 6, there'd be just a little hole in the graph right there, all right? So something like that. All right, then 21, we've got this function. First thing we're gonna do is go ahead and graph that and see where the zeros are. So I'm gonna get rid of this and type this in, x to the 4th, plus 7x to the 3rd, plus x squared, minus 23x, and then minus 210. All right, put it in my regular window. And we see we got something going on here at -7 and at +3. So as far as roots go, or zeros, or whatever you want to call them, -7, +3, we know those are 2. The other 2 didn't show up, so they're probably imaginary. What we need to do is go ahead and divide this. So this is the fun exercise of dividing polynomial function. You'll only have to do this once on your exam. But what we do again is we say what multiplies by this to make it equal that. That would be x to the 3rd. So I multiply by x to the 3rd. It's going to cancel everything. So then the x squared comes down. And then I'm also going to bring down the -23x. Okay, so we're kind of skipping over the x squared. There isn't anything for that. But then what do I have to multiply x by to make it equal x squared? That would be just a plain x. So I do that. When I subtract, I'm going to get -30x. And then bring that down. What do I have to multiply that by to make it equal this? A -30. And so we go ahead and do that. And everything comes to 0. Remember, the 0 is what you need to have. When the 0 happens, you feel good because that's pretty much guaranteeing that you did this right. If you don't get 0, go back, check your work. All right, now we got to take this x to the third plus x, and I'm going to put 0x squared plus x minus 30, and we're going to divide that by the other root, which is x minus 3. All right, so what do I have to multiply this by to make it equal that? X squared. That gives me x to the third minus 3x squared. When I subtract, 0 minus negative is a positive 3x squared. Bring the x down. Multiply that to here, gives this 3x. So 3x squared minus 9x. When I subtract, that becomes 10x. Bring the negative 30 down. And then we're going to have a positive 10 there. And again, everything comes out to 0, which is great. That's what I want. Okay, so what I'm left with is this x squared plus 3x plus 10. This is where the two imaginary roots are located. So we're going to use a quadratic formula on that. We're going to have opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's going to give us negative 3 plus or minus the square root of negative 31 over 6. And all I want you to do is pull that negative out, make it an I. So our other two roots, negative 3 plus or minus the square root of 31 I over 6. This would be our solutions then. Okay. All right, last page deals with logarithms. So remember, ln, natural log, that's a log base e. So if we want to kind of undo this, we'd have e to the first equals x, so x just equals the number e. That's all we're doing for that. Same thing here, we're going to undo this. So 4 to the third power equals x, so I get 64 equal to x there. All right. For this one, if we undo that, we get x to the 2/3 equals 25. So if I get, anytime I have a exponent that I don't want, I can always do it to the reciprocal exponent. So I'm gonna, that'll kind of, when they multiply, they cancel out. I get x equal 25 to the 3/2. So the half is square root. Square root of 25 is 5. Then 5 to the third power gives me 125. So do the root first, then multiply up. You can do it the other way, but that would be a lot harder on something like that. All right, here we have an exponential. We aren't happy with that, so we're going to switch it into a logarithm. The log of 12.098 base e, which makes it a natural log, is equal to x. And then we can just take our calculator and go natural log of 12.098. And we get x equal to 2.493 if you round to 3 decimal places. Okay. For number 26, we're going to have to use our log rules here. So when we have two logs like this, same base, we're going to put them together by multiplying what's inside. So it's going to be x times x minus 1. I'm going to go ahead and distribute that, which gives me that right there. Then we can undo the log. So 4 to the 1/2, square root of 4 is 2. All right. If I subtract that 2 over, I get x squared minus x minus 2. That factors into x minus 2x plus 1, which means x equals 2 or negative 1. Now initially that's what we have, but when you look back at the original, I can't take the log of a negative number, so you got to throw that one out. X equal 2 is your only option. Okay. And then here we can set up a log. The log of 729 base 3 is equal to x, and I can take the calculator, go math, and log base is this one here, and I can go ahead and set that up with base 3 and 729 inside. I get 6 for an answer. Or if you don't have that log base, you do log 729 divided by log 3. That'll get to you too. All right, our last question here says a deposit of $6,700 is made in a savings account, compounded continuously. The balance is 5 years, is predicted to be $8,400. So that's what we're going to end with, $8,400. 6,700 is what we started with, and we're doing this in 5 years. But at what interest rate? That's what we're trying to figure out. So we're going to divide by 6,700. All right, so if we go 8,400 divided by 6,700, we end up with this number here, 1.253, blah, blah, blah. All right, let me just move that over. 1.253 da 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 equals e to the 5r. It's an exponential. I don't like it. So we're going to switch it into a log. Log of 1.253, blah, blah, blah. base e, which means this will be a natural log, equals 5r. So I'm now going to take the natural log of that big number right there, and that gives me this. So 0.226 blah 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 equals 5r, and then we're going to divide it by 5. So our interest rate is 0.04522, or 4.522%.